Hello everyone, welcome to lecture 3. So in today's class we learn about some interesting topic and we solve some math. So let's start the class. First we learn about application software. This is the program you write to do something useful like a game, calculator or web browser. It's been an application just like you can say about that one of the apps we use for social media. This is Facebook. So Facebook also a application software. So write in a written in high level language. High level languages means the code we write in compiler. This type of code, Python, Java, C++, these are called high level language. Now let's learn about system software. This include programs that help run your computer and help your application work. So system software, it's just like a compiler. Compiler compile your code. So compiler is a system software which translate your high level language code into machine code ones and zero that the computer hardware can understand. You all know that only binary number can computer can understand. Other languages computer is not understand, so that we use compiler. For example, we write this code in C++ and compile to object code, and object code compile it to binary language which is readable for a computer. So this is the way how it's work. So now let's learn about operating system. We all know that what is operating system. um, you can for example, we use our laptop desktop which is operated by Microsoft. We use Microsoft operating system. Some of are using MacBook which is with operating system, and also we use phone. In phone we use Android. So these are the operating system which the OS helps everything run smoothly. It does things like handling input output, keyboard, mouse, screen. Yes, managing memory and storage, keep track of where things are saved and what memory is being used. Scheduling tasks and sharing resource, make sure different program run fairly and efficiently. Basically, the operating system help us to operate a device. So now go to hardware. Without hardware anything cannot be possible, because without hardware we cannot run a code. We cannot write code. So hardware is important. Because why hardware is important we learn about in this class. So let's talk about hardware. This is the physical part of your computer. It includes processor, CPU, does the actual work. This is the, for example, of a computer head of a computer. Memory RAM where storage are data are stored. Input output controller handle input output. Keyboard mouse is used for input device, and output devices are screen, printer. These are the output device. So these all of are the hardware. Let's see a image of hardware. These are the hardware. This is our motherboard. This is the hard disk, DVD driver. This is monitor. This is our RAM, mouse. This is also RAM. So these all the hardware devices which are installed in our motherboard, and then we can run our computers. So how it's work? First, we high level language easy for human, portable and productive. Then high level language is compiled to assembly language, closer to machine, user simple text for instruction. Then it converted to binary, which is machine code, which is 0 and 1. Actual zeros and ones the computer run. So that's the way it's work. So go to the next topic, which is instruction set architecture. Short form is ISA. So what is ISA? ISA is the set of instruction a computer can understand. It connects software and hardware. So it's a connection between our software and hardware. So this connection help the code or program run smoothly. So that's why it is very important. So here why it's important. So programmer write code using ISA instruction obviously, then hardware engineer build CPUs to follow those instruction. This let them work independently but still stay compatible. Of them hardware and software are run independently but they compatible. So what is ISA? If we describe it some short sentence, this is a register, is small, fast storage in the CPU. Data transfer method, how data moves between CPU, memory, and input-output devices. So basically, ISA helps the hardware do its job faster and better. I hope you understand what is ISA. So now let's go to the our next topic, which is computer architecture, which is also the name of our course, which is computer organization and architecture. These are the organization and this is the architecture. So what is the architecture? Architecture refer to the parts of a computer system that affect how program run and behave. So it's affect how program run and behave. Architecture and organization refer to the physical part, in hardware part of the computer, how they are built. So hardware, we can use lots of type. There is lots of processor, which is Intel, AMD, Ryzen, this type of processor. Also Core i3, Core i5, Core i7. It's up to you. You use which type of processor to build your computer organization. So these are the organization of computer, the physical component of your computer. These details are usually hidden from the programmer. So programmer only write code using keyboard. So they did not see what is inside the computer. So let's learn about how CPU design. This is the process of creating a processor. We already talked about in lecture 2 that how processor can build. So how it is designed, let's learn about this. So step involves which are define instruction set, decision what instructions, decide what instruction the CPU can understand and execute. Design data path and control hardware. Data path moves and process data. Control unit direct how the data path works for each instruction. So what is now implementation in FPGA? Use in FPGA, which is a chip you can program to act like your CPU. Great for testing and prototyping before making a real chip. Now last of all is verify. Make sure the CPU works correctly by running tests. So verification also is very important for design a CPU. So let's go to our another topic. What's affect a computer program's performance? This is very important. We basically learn about this type of things in this course. So this is very important, and you should memorize all things we cover in this topic. So what is algorithm? Algorithm decide how many steps the program needs. A better algorithm is equal fewer opportunity, if fewer operations is equal faster program. Programming language and compiler. So affect how many machine sorry affect how many machine instructions are needed for each operations. Some language compiler produce more efficient code than other. For example, if you use C++ for write your code, and another of your friend, for example, he use Python. So when we compile both of these, the C++ is more faster. If you use C++, then it is easier for you to write a faster code. So that's why programming language and compiler. Also compiler, we can there are lots of type of compiler. For example, VS Code, code blocks. This is the compiler. Also compiler capacity also important here, because if the compiler run the code faster, then you get the output faster. So this is this that's why how it's important. Now let's learn about processor and memory system. Control how fast the CPU run, instruction and access data. Faster processor or memory, better performance. Obviously, input output system including operating system affect how quickly the program can write data, write data. Slow performance even if CPU is faster. Slow input output affect the CPU. So this is the formula for calculating CPU time. CPU time is equal to CPU clock cycle, and clock cycle time or CPU time is equal to CPU clock cycle and clock rate, because clock cycle is equal to clock cycle time is equal 1 by clock rate. So you know the formula, then let's solve a one problem. So you can clear your understanding by solving the problem. So this is the our data computer A, which is 2 gigahertz clock, and time is 10 seconds, which is CPU time. We have to design computer B, and for 6 seconds CPU time can do faster clock, but cause 1.2 into clock cycle, how fast must computer be clock. So let's start. Our given data is first data is clock rate, which is 2 gigahertz. 2 gigahertz mean 2 into 10 to the power 9 hertz. Then the CPU time is CPU time which is 10 second. So this is the information for a computer A. So let's find clock cycle for computer A. We know the formula. CPU time equal CLOCK clock cycle divided by clock rate. Clock rate. So this is the formula. Now let's put all the value here. We know that CPU time is 10 second. We did not know clock cycle, but we know the clock rate, which is 2 into 10 to the power 9. Then if we find clock cycle from here, then clock cycle, let's write CC, this is indicate clock cycle, then 2 into yes 20 into 10 to the power 9. So this is the clock cycle for computer A. Now we find the clock rate, because the requirement of the question is how fast must computer be clock B. So if we find the clock rate, then we easily say that it is faster or slower. So for we use same formula, CPU time, which is 6 for computer B, then clock cycle we find from here 20 into 10 to the power 9, also multiply with 1.2, which is also given in our question. So multiply by 20 into 10 to the power 9, then clock rate. So clock rate, just write CR, then 1.2 into 20 into 10 to the power 9, then divided by 6. That's fine. Calculate the value. What we get? 1.2 into 20 into 10 to the power 9, then divided by 6. We get 4 into 10 to the power 9 hertz. So we can also write this as a 4 gigahertz. So This is the our requirement value and this is our answer. Let's go to the another formula which is also very important, which is CPI, clock cycle per instruction. CPI is equal to clock cycle divided by instruction. So this is the another formula you can write also. Clock cycle is equal, because if we write clock cycle here, then these two are multiplied. This this is the formula. Clock cycle is equal to instruction count into cycles per instruction. CPU time is equal to, if we put this value here, so this is the formula. I hope you get it. So now let's solve a problem. Same ISA. Same ISA mean our instruction sorry, instruction count, sorry. ISA means instruction count is same for A and B. Which is faster, how and how much? So there are the given value, which is cycle time. We know the formula. Here is CPU time is equal instruction count, CPI, clock cycle time. Here is the, we have the value of cycle time, then CPI, and instruction counter same. We have to find the CPU time. So CPU time for A, CPU time for A. CPU time for A, which is instruction count into CPI into cycle time. Then we can write, let's denote this by L into CPU time. CPI is 2, then 250. So 500 L. Now let's find for B, CPU time for B. CPU time B, instruction count, then let's see what are the value. 1.2 is CPI and 500. 1.2 to 500. So we get the value, which is 600. So CPU time is lesser in CPU in A computer, so A must be faster. Now let's another formula. So let's learn another formula. Clock cycle. Clock cycle is equal to CPI into instruction count. CPI into instruction count, which is equal to clock cycle. So these are the question for us. We have the value of CPI. These are the value of CPI, and this is the instruction count, which is 212 and 411. So let's solve the question. Which code sequence execute the most instruction? Most instruction. So we have to sum all of this value to code sequence 1 in 1. Here instruction are total instruction. Instruction 2 plus 1 plus 2, this is 5. And for 2, this is 4 plus 1 plus 1, which is 6. So these are the value. CPI, what is the CPI for each sequence? For each sequence, which will be faster? So for each sequence we have to calculate. Let's calculate here. For 1, we know the formula, clock cycle is equal, let's denote clock cycle by CC, equal CPI into instruction count. CPI is 1, instruction count is 2. CPI is 1, instruction count is 2, plus this is the value. Here is CPI is 1 and clock instruction count is 2. Then 2 1, then 2 into 1 plus what about the last one, 3 into 6, 3 into 3 into 2. So the value is equal 4 plus 6 10. Clock cycle is 10 for sequence code 1. Now let's find for 2. Clock cycle 1 4 2 1 3 1. 1 4 2 1 3 1. Then value is 2 3 5 9. So this value is 9. So if we calculate how faster, then we have to divide it with this value. Then for sequence sequence 1, we have to divide it by 5. And this is 2. And what happened? Then CPU time is 6 for 2. Then 9 divided by 6 is 1. Oh, sorry, 1.5. So this is the average CPI. So this one is faster. Now why this is faster? CPI, this is cycle per instruction, is lower in sequence 2, which is 1.5, and despite having more instructions, sequence 2 uses fewer total cycle. So sequence 2 is faster because it requires fewer total CPU cycles to execute. This is the average CPI. So this one is faster. So that's all for today. See you in the next class.